Bismillah ar-Rahman ar-Rahim. We'll continue. We did this one. That was the last one we did. Now we'll go to the next one. See, we have this is the solution, function of x, y is a function of x, with this initial value problem. So I need first to solve this, then I need to find the c's through these conditions. So this one will be what? Auxiliary equation, r squared plus 16 equals 0. So that means r is plus or minus 4i. Yeah, so y, the general solution, y will be c1 sine 4x plus c2 sine 4x. Now I need to condition, I need to find y prime first. So that will be minus 4c1 sine 4x plus 4c2 cosine 4x. Now I need the conditions. Y at 0 will be 2. That implies to substitute 0 there. I have c1 cosine 0 is 1. Sine 0 is 0, that's it. So c1 equal 2. Y prime at 0 equal minus 2. That implies here if substitute x equals 0, I have 0. So I have 4c2, since cosine 0 is 1, is equal to minus 2. So c2 equals minus half. So what will be y? The solution. Y will be c1 is 2 cosine 4x minus half sine 4x. Now what I need? Y at pi over 2. Y at pi over 2, it will be 2 cosine 2 pi, correct? Pi over 2 times 4 is 2 pi, minus half sine 2 pi. Sine 2 pi is 0, cosine 2 pi is 1, so the answer is 2. And that will be the answer. Okay, the general solution of this equation, this is the auxiliary equation, will be what? R cubed plus 3r squared plus 3r plus 1. Yeah. Equals 0. What is this equation? Yeah, you can by guessing, by inspection, r equal minus 1 is a root. So you have 1, 3, 3, 1 with minus 1. Have 1 minus 1, 2. Minus 2, 1. Minus 1, 0. So I have r cubed plus 3r squared plus 3r plus 1 is r plus 1 times r squared plus 2r plus 1. What is this? This is r plus 1 all square. And that will be r plus 1 cubed. So the roots are what? R minus 1 minus 1 minus 1. What will be the general solution? Y equals c1 is minus x. C2 x is minus x. C3 x squared is minus x. And that will be my answer. A homogeneous linear differential equation with constant coefficient. Now this is the general solution. If that is the general solution, so what are the roots? Are minus 1 plus or minus I. So the auxiliary equation will be R. So I have the roots minus 1 plus I minus 1 minus I. So you have R minus 1 plus I times R minus 1 minus I equal to 0. So I have what? R plus 1 minus I, and this is R plus 1 plus I equal to 0. So I have R plus 1 square plus 1 equals 0. So I have R square plus 2R plus 1 plus 1 plus 2 equals 0. So what will be the differential equation? Plus 2y prime plus 2y equals 0, which is this. You can do it easier than that, but just to be sure. Okay. Which one of the following set of functions is linearly dependent? Okay. This one very clear. It will be independent. Yeah. Also this one x e to the power x, x e to the power minus 2x. So there is no scalar multiplication of these two. Also, this one, they are different. This one will be the linear independent. This linear independent, I will prove this. And the rest, I think, we need the Wronskian, or we can just by yes, they are very clear, I think. So I have note y1 equal e to the power x plus 2. This is what? E squared e to the power x. And y2 e to the power x minus 3. This is e to the power x is minus 3. In other words, e is minus 3 e to the power x. So they are constant multiple of e to the power x. So now if I put c1 y1 plus c2 y2 equals 0, can I choose c's so that I have this relation? So I have e squared e to the power x, and here I have c2 is minus 3 e to the power x. I can choose c1 to be minus e is minus 2. So this will be minus e to the power x. And I know I choose c2 e to the power 3. So that gives me minus e to the power x plus e to the power x, which is 0. So this is for sure linear dependent. The rest, I think you can do it either by inspection or by Wronskian. If y equals c1 plus c2 plus c3 plus c4 plus c5 is the general solution of this differential equation. Okay. Okay. So he did what? This one, the auxiliary equation, what will be the auxiliary equation? It will be 2r to the power 5 minus 7r to the power 4 plus 12r cubed plus 8r squared equals 0. Very clear, I can take r squared common factor. I have 2r cubed minus 7r squared plus 12r plus 8 equals 0. This will give me 0, 0. And that will be, this will be the general solution from that. This part of the general solution will cover this 0, 0. So now we need to work out with these ones. And they need to find somehow to solve this. But he gave me this. East minus half is a solution. So you have a root r equal minus half. So this is one of the roots. So I can do the synthetic division to find that root, to deal with that root. So I have 2 minus 7, 12, 8. Minus half is a root. So I do the calculation. 2 times minus half, that will be minus 1. That's minus 8. Minus 8 times minus half, that's 4. That will be 16. That will be minus 8. 0. That means this is what? R squared, R plus half, or 2R plus 1. Since it's, yeah, I can say R plus half, times 2R squared minus 8R plus 16 is equal to 0. As I said, this give me 0, 0. This one give me minus half. Now this one, I need the quadratic formula to get it. Since this seems to me that I'm getting another real solution. So I have R equal minus B, 8, plus or minus square root, B squared, 64, minus 4AC, 4 times 2 times 16, over 2 times 2 over 4. Okay. So that will give me what? 8 plus or minus. I have 64. Also, I have here 64. Yeah. Uh, 4 times 16 is 64. So I have plus or minus 8. You know what? 16 times 8 is what? 8 Do it the way you like. 128. 128 minus 64. That will be 64. So I have this one square root minus 64 over 4, which is 8 plus or minus. What is the square root of minus 64? It says 8i over 4. So that will be 2 plus or minus 2i. Okay. So my roots, this one give me what? 2 plus or minus 2i. So the general solution will be C1 plus C2x plus C3 is minus half x, which is these are the three things. And this one I need sine and cosine. C4 e to x cosine to x plus C5 e to x sine to x. So what is alpha? So will be my alpha. Or this is B, sorry. This is B, using B. And this one is C. Okay, so B equal to C equal to, so B square plus C square will be 4 plus 4, which is 8, which is this one. Okay, the solution of this initial value problem, I need to solve this. So auxiliary equation will be what? R cubed plus 12R squared plus 36R equals 0. It can take R. I have R squared plus 12R plus 36 equals 0. I need to solve this. This is R, and this is what? R plus 6 all square equals 0. So the roots are 0 minus 6 minus 6. So what will be the general solution? Y will be C1 plus C2 e minus 6x plus C3 x e minus 6x. Okay. I need y prime and y double prime. So let me find those things. Y prime will be minus 6c2 e minus 6x. This one, product of two functions, c3 minus 6x minus 6c3x minus 6x. I need y double prime. That will be 36 c2 e minus 6x minus 6 c3 e minus 6x minus 6 c3 e minus 6x plus 36 c3 x e minus 6x. Okay, I need a space. I will try to do it here. Y at 0 equals 0. I'm getting what? C1 plus C2. This will be 0 equals 0. Y prime at 0 equal 1. Now I have minus 6 C2 plus C3 equals 0. Y double prime at 0 equal minus 12. I'm getting what? 36 C2. And this one minus 6 minus 6 minus 12 C3 equals 0. I need to solve this system. So let me take these two equations. When I can deal with it easily, multiply the first one by 6. I have minus 36 C2 plus 6 C3. It's not 0, sorry. These are not 0. These are 1. This is 1. This is minus 12. Okay, this is multiplied by 6. That will be 6. This 36 C2 minus 12 C3 equal minus 12. Add them. These cancelled. I have minus 6 C3 minus 6 C3 equal minus 6. So C3 equal 1. So I plug it here. I get what? Minus 6C2 plus 1 equal 1. So minus 6C2 equals 0. So C2 equals 0. Plug it in the first one. So that implies C1 plus 0 equals 0. So C1 equals 0. So what will be my solution? Solution will be y equal C1 is 0, gone. C2 is 0, gone. And C3 is what? 1. So I have x e minus 6x, which is this. If this one is the solution, it's the homogeneous differential equation with fundamental set of solutions. What do I mean by fundamental set of solutions? Means the set of the basis, let me say, the basis for the solution space. Yeah, fundamental set of solution. This is because they combine also some questions from Math 202, where they're using fundamental set of solutions for the basis for the solution space. Okay. Contains these functions. Say the basis for the solution space contains these functions. So if it contains this, and then it means it contains is minus 10x also. If it contains this, then it contains is minus x cosine x. So the roots are what? I have this and this. I have minus 10 repeated. Actually, from here, that will give me minus 10 repeated. Here I have the non-real, which is minus 1 plus or minus I. Actually, I need 4 roots because it's fourth order differential equation. So this is the fourth root. I can get the auxiliary equation to be what? R plus 10, R plus 10, and this one R minus these are what? Minus 1 plus I minus 1 minus I. So let me do it quickly. R minus this, so it will be R plus 1 minus I, and R plus 1 plus I is equal to 0. So I have R plus 10 times R plus 10. This is R squared plus 20 R plus 100. These ones are what? R plus 1 square, okay, plus 1 equals 0. So I have R squared plus 20R plus 100 times R squared plus 2R plus 2. Yeah, I need to do the calculation now. I have what? R to the power 4. Now to get R cubed, I need 20 times this and 2 times R squared. That's the only one which will bring R cubed. Yes. So I have 22 R cubed. 22 R cubed. Okay. Now, what will bring R square? Yeah, I need to be careful here. What bring R square? R square times 2. 20R times 2R. And 100 times R square. So it's 2 plus 40 plus 100. That it is 2 plus 40 plus 100. So it's plus 142 R square. Okay. What will give me R? This is 2R. This is R square. What will give me R? 20R times 2 and 100 times 2R. That will be 40 plus 200 plus 240R. What give me the constant? Plus 200 equals 0. So what will be the differential equation? Y, the fourth root, plus 22, third derivative, 142, the second derivative, plus 240, the first derivative, plus 240, let y equals 0. That will be the differential equation. Now, what will be A and what will be B? A is the coefficient of the third derivative, so that will be A, and that will be B. So A plus B will be 22 plus 142. That will be what? 164, which is this. Yeah. Solve this. So you have the auxiliary equation, r cubed minus r squared minus 4 is equal to 0. Now I need to solve this one. And I guess if I deal with A0 minus 4, AN 1, so P plus or minus 1, plus or minus 2, plus or minus 4, Q plus or minus 1. So B over Q will be plus or minus 1, plus or minus 2, plus or minus 4. You check R equal 1, that will be what? 1 minus 1 minus 4, not equal to 0. R equal minus 1, minus 1 minus 1 minus 4, not equal to 0. So it's very clear the negative value will not give you an answer because this will be negative, this will be negative, that will be negative. So just I need to check the positive values. R equal to, I need 1 to reduce the third to the second because the second I can find it. 2 give me what? 8 minus 4 minus 4, which is 0. So 2 is okay. So I will deal with 2. That will be 2. 1 minus 1, 0 minus 4. 1, 2, 1, 2, 2, 4, 0. So I'm okay. So this one, r cubed minus r squared minus 4, actually it's r minus 2 times r squared plus r plus 2 equals 0. So this one, give me r equal 2, but this one, I need the quadratic formula. R will be what? Minus b plus or minus square root of b squared 1 minus 4ac minus 8 over 2. That will be minus half plus or minus square root 7 over 2 I. So it will be my general solution. Y equals C1 e to x plus C2. This is alpha is minus half and beta is square root of 7 over 2. So plus C2 is minus half x cosine square root 7 over 2x plus C3 is minus half x sine square root 7 over 2x. That will be my general solution. Okay. Of order linear fourth order. He said it's fourth order. Okay. With constant coefficient having these roots. So I have M2, M3 equals 0. But this one, since it's a real coefficient, you should mention real coefficient. So I need, and I noticed from this, all the coefficients are real. So M1 is there, means I have M4, 1 plus C is a root. If that is the case, so it will be the auxiliary equation. It will be r minus 0, r minus 0, oops, times r minus 1 plus 7i times r minus 1 minus 7i equal to 0. So you have r square and you have r minus 1 square. This is plus 49 equals 0. So you have r square minus 2r plus 1 plus 49 plus 50 equals 0, which is r to the power 4 minus 2r cubed plus 50r squared is equal to 0. So it's the equation, the differential equation, the fourth root, the fourth derivative, minus 2, the third derivative, plus 50 y double prime equals 0, which is this one. Yeah. Okay, let me do more. given y equals C1 cosine plus the general solution of this differential equation. Then I have this initial value problem. He said it has a unique solution, has no solution. I need to check. I need to find the C's. Can I find only one C's or I'll find different C's? We'll check. So this is the solution and this is the condition. So I need y prime. Y prime will be what? Minus C1 sine of ln x times 1 over x plus C2 cosine ln x times 1 over x. Okay. Now I need the condition. I have these conditions. So y at e to the power pi over 4, wow, equal to square root of 2. What I will get? Substitute in this one. I have, let me do it easily, C1 cosine ln e pi over 4 plus C2 sine ln e pi over 4. Okay, that should equal to 2 square root of 2. So I have what? Yeah. Cosine, this is ln e pi over 4, it's pi over 4. Cosine pi over 4 is square root 2 over 2. And the same thing here. C2 plus C2 root 2 over 2. That equal to square root of 2. Okay. So I need to simplify this. Multiply by 2 over root 2 to cancel this. We have C1 plus C2 equal what? 4. That will be the first equation. Now we'll do the second one. Y prime e pi over 4 is equal to 0. So I substitute there in this one. Yeah, that will be a little bit complicated. Let me see. I have what? Minus C1 sine ln e to the power, we know this, square root 2 over 2. We did it before. Times 1 over x times e is minus pi over 4 plus c root 2 over 2 also. Cosine ln x, which is root 2 over 2 times e minus pi over 4, 1 over x. That's equal to 0. So I multiply in this case by 2 over root 2 and e to the power pi over 4 to cancel everything. So I have what? This is minus C1, this is cancelled, plus C2 equals 0. So C1 equals C2, plug it here. So I have 2C1 equal 4. So C1 equal 2 and C2 equal 2. So what will be my solution? It will be y equal 2 cosine ln x plus 2 sine ln x. So for sure I have a unique solution. No solution, no. Infinity minus solution, this is wrong. I have only one solution. Now we need to check e to the power pi over 3. Yeah. So I have y at e to the power pi over 3. That will be 2 cosine pi over 3, which is half, and sine pi over 3, which is square root 3 over 2. So I have 1 plus square root of 3. So this will be my answer. Okay, find the general solution of this. I need the zeros. This one give me 0, 0, the roots. I need to do it by the quadratic formula. I have minus 1 plus or minus square root 1 minus 4 AC over 2. So it's minus half plus or minus square root 3 over 2. This one is, this is, by the way, d plus 3 all square. So the roots are minus 3 and minus 3. Okay, so it will be the general solution. Y equals C1 plus C2x plus C3 is minus 3x plus C4 x is minus 3x. I get rid of this. This one I need the non-real case. C5 is minus half x cosine square root 3 over 2x plus C6 is minus half x sine square root 3 over 2x, which is very clear. This will be the answer. Two roots of a quadratic auxiliary equation are this. Then the corresponding second order. Alas, I need two roots. These are the second order. So what will be the auxiliary equation? Will be r minus 1 minus 2i and r minus 1 plus 2i is equal to 0. So I have r minus 1 square plus 4 is equal to 0. I have r square minus 2r plus 5 equal to 0. So it will be the differential equation y double prime minus 2y prime plus 5y equals 0, which is this one. Find the general solution of this differential equation. Okay, I need to do it one by one. Yeah, this one, I need the quadratic formula. Don't forget I have square, so I just double the roots. I have r equal what? Yeah, I can write the auxiliary equation. Yeah, the auxiliary equation are what? R square minus 2r plus 5 square r cubed plus 2r square plus r plus 2 equals 0. This one, to find the root, I need to do it by the quadratic formula. 2 minus b squared 4 minus 4ac over 2. That will be what? This is 4 minus 16. 4 minus 20 is minus 16. So this is 4i. That will be 2 plus or minus 4i over 2. That 1 plus or minus 2i. Okay, this one, I think it needs some calculation. I can take r squared common factor. I have r plus 2 plus r plus 2. Then I have r squared plus 1 times r plus 2. So the roots here, the roots are plus or minus I and minus 2. So what is the total roots? All roots are what? 1 plus or minus 2i plus or minus I and minus 2. So the general solution, C1e minus 2x plus C2 cosine x plus C3 sine x plus C4e x cosine 2x. Oh, don't forget, these are repeated. So I have the 4 roots. Yeah, I forget that. Let me write minus 2 plus or minus I and 1 plus or minus 2i repeated. So I need C4 plus C5x e to the power x cosine 2x plus C6 plus C7x e to the power x sine 2x. And that will be my answer. Yeah. A linear differential equation that annihilates the function. I changed the question, so I will delete this. A linear homogeneous constant function difference has the general solution this. Actually, it's not the general solution. It should not be the general solution, which has a solution. Or let me say, part of the solution. Let me check how we stated before. Not general solution. Since that y is a solution. This is one way to state it. Also, the other way, I think we saw a question here. not general solution, where basis contains these functions. Okay, which has y as a solution, as as a solution. So this is part of the solution, or it's yeah. Let us see what is y. Y will be 4 minus 4ax plus e to x. So if I think of it, this 4 will come if I have 1 is a solution. So you have C1 times 1, where C1 is 4. This one will come if I have C2 e to the power x, where I choose C2 to be minus 4. This one will come if I have C3 e to x. So those are the solutions. Okay. So the roots are what? 0, 1, and 2. If these are the roots, what will be the auxiliary equation? Will be r minus 0, r minus 1, r minus 2 is equal to 0, which is r, this is I have r squared minus 1 minus 2 minus 3r plus 2 equals 0. So I have r cubed minus 3r squared plus 2r equals 0. So what will be my differential equation? It will be d cubed minus 3d squared plus 2d times y equals 0. Those are solution, not the general solution. Okay. So I can choose C's. Satisfy those. Which one of the following cannot form a basis for the solution space? They are bases, third order. It means what? I need 3 linear independent solutions. So I need them to be 3 and linear independent. There should be 3 and linear independent. These are 3 and they are linear independent. This is can. Oh. These are 3 and linear independent. You can check through maybe Ronscan. These are 3 and linear independent. These are 3 and linear independent. They come from. They are not linear independent. These are linear dependent. Why? Because if I know that sine hyperbolic is what? Half e to the power x minus half e minus x. So I can write C1 ax plus C2 e minus x plus C3 sine hyperbolic x equals 0. And I can choose the c's this way. Let me choose this to be 2. So I have e to the power x minus half e to the power x. I'll choose this one to be minus 1. So e to the power x will be killed with this one. Minus e minus x, I'll choose this to be 1. So this is linear dependent. Yeah, by the way, I'm trying to restate some of the questions which was for Math 202 to be in this section, because I tried to combine all questions, all the exams questions for Math 202 and Math 208 in one file. Okay. Okay. Given this, it's a 2-parameter family of solutions. A member of the can satisfies this is given by what? Now I have these conditions. So this is y. I need y prime. When I have what? This is product of two functions, ax cosine x plus c1 ax minus. Because the derivative of cosine is sine minus sine x. Now it comes to c2, I have c2 ax sine x plus c2 ax cosine x. Now I have y at 0 equal 1. That implies what? E to the power 0 is 1, cosine 0, I have c1. This is c2, sine 0 is 0, gone. So I have c1 equal 1. y prime at pi equals 0. If I put pi, I have what here? C1 e to the power pi times minus 1. Sine pi is 0. Sine pi is 0. Here I need another pi plus C2 e to the power pi times minus 1. That should equal to 0. So let me make this. C1 equal 1. Plug it here. So I have minus a pi plus C2 minus a pi equals 0. So I have C2 minus a pi equal e pi. So C2 will be minus 1. So what will be my solution? Y will be C1, which is 1, ax cosine x, and that minus 1 minus ax sin x, which is this one. Okay. Given that the parameter is a solution, then the differential equation has a solution satisfying these boundary conditions. Okay. Yeah, I need to check all of these. So I have y equals C1x squared plus C2x to the power 4 plus 3. I need y prime actually in only one, but let me find it. That will be 2C1x plus 4C2x cubed. Okay, let me do E. Y, he said what? Has a solution, satisfying the boundary conditions. Okay, let me check y minus 2 equals 0. That implies what? I put in x minus 2, that will be 0, equal 4C1. This is the power 4. So I have 4C1 plus 16C2 plus 3. That should equal to 0. Now, if I put y at 2 equal 2, I'm getting what? 4C1 plus 16C2 plus 3 equal 2. Impossible to have the same thing is equal to 0 and equal to 2. So this is means no solution. D, the same idea. Y at minus 1 equals 0. I have one. Since this is x squared and x to the power 4. So plus or minus will not change it, huh? Okay. So y at minus 1 equals 0. I have what? I have C1 plus C2 plus 3 equals 0. Now y at 1 equal 4. I have C1 plus C2 plus 3 equal 4, which is impossible. So no solution. This is D. C, y at 1 equal 3. That implies what? C1 plus C2 plus 3 equals 3. And y prime at 0 equal 1. This is y prime. So I have 2C1 plus 4C2 equals what? Equals 1. If I notice from here, I have C1 plus C2 equals 0. Okay. Y prime at 0. Sorry. This is y prime at 0. So I have substitute this one. I have 2 times 0. I have 0 plus 0 equals 1, which is impossible. So no solution. No need for this step. Now B, I have what? Y at 0 equals 0. I have what? Y at 0 equals 0. That will kill it. I have 3 equals 0, which is impossible. So no solution. Now we'll come to A. Y at 1 equals 3. I have what? C1 plus C2 plus 3 equals 3. And then Y at 2 equals 15. I have Y at 2. I did it for 4C1 plus 16C2 plus 3 equals 15. From here, I get C1 plus C2 equals 0. So that means C1 equal minus C2. Plug it here. So I have what? Minus 4C2. Since C1 is minus, plus 16C2. This is 3 equals 12. So 12C2 equals 12. So C2 equal 1. So C1 equal to minus 1. So I have a solution. My solution will be y equal minus x squared plus x to the power 4 plus 3, which satisfies this. Yeah. Which one of the following sets form a basis for the solution space of a third order? Third order, how to make a basis? I have 3 linear independent solutions. Okay. These are not linear independent. These are dependent. I know I can do this C1 AX plus C2 is minus X. I think we did it before. Yeah, we did it before. Yeah, the first one, they are linear independent, very clear. I have minus 1, 1, and 2. Okay, that will make it 0. So they are linear independent. So they cannot form a basis. This one we have only 2. Cancel. We have only 2. Cancel. I need 3 linear independent solutions to have a third order, to be basis for the solution space of a third order differential equation. This one also they are linear independent. Why? Because I know cosine hyperbolic minus sine hyperbolic equal Ax. So I can do C1 sine hyperbolic plus C2 cosine hyperbolic plus C3 Ax equals 0. And I can choose the constant how? I choose this one, and this is minus 1. So if I have cosine minus sine, this is e to the power x, choose this to be minus 1. So this is make it linear dependent. These are linear independent. This one will be for sure independent. You can do the Wronskian. I will do the Wronskian, no problem. Let me start with 1, 0, 0. Sine hyperbolic. That will be cosine hyperbolic. That will be sine hyperbolic. Cosine hyperbolic. That will be sine hyperbolic. That will be cosine hyperbolic. Now with 1, cancel this with this. I have cosine hyperbolic square minus sine hyperbolic square, which is equal to 1, not equal to 0. So it's linear independent and 3. So they can't form a third order, a basis for the solution space of a third order linear differential equation. Yeah. Let me do 2 more. A linear differential equation that not annihilates, as I change this. Cancel. A linear differential equation which has, not the general solution, sorry, which has y as a solution. So this is the solution. So if I have 8x as a solution, it means I have C1 plus C2x. I cannot reach 8x, where C1 is 0 and C2 is 8. So from this, I'm getting the zeros, 0, 0. I have sine x, it means I have sine and cosine, so I'm getting the zeros, plus or minus I. This one, I have the zeros, minus 1 plus or minus I. Now I need to combine all of this to find the auxiliary equation, then I can find the differential equation. What will be the auxiliary equation? It says they have this as a solution. So that will be r squared. This will be what? R squared plus 1. This one I need to do it. R plus 1 minus I times R plus 1 plus I is equal to 0. So I have here R to the power 4 plus R squared. This one I have what? R plus 1 squared, which is R squared plus 2R plus 1 plus 1 plus 2 equals 0. Now I can do the calculation. I have what? R to the power 6. Then what? Which one will bring to the power 5? This times this. So plus 2r to the power 5. To the power 4, I have this, I have this, I have plus 3r to the power 4. To the power cubed, I have r squared times 2r. That's the only things. So I have plus 2r cubed. R squared, I have r squared times 2. That's it. So I have plus 2r squared. And that will be the auxiliary equation. So it will be the differential equation, the sixth derivative, the fifth derivative, 3, the fourth derivative. Okay, given my this is a general series second order boundary conditions, A not equal 0 has infinitely many solutions. When it has infinitely many solutions, if B equal what? So let me do the conditions. I don't need y prime. Y at 0 equal A. I have what? A 0. I have C1. A equals C1. Y at pi equal B. I have what? Yeah, cosine sine 0 is 0. So this is gone. Cosine 0 is 1. E to the power 0 is 1. So if A equals C1, or let me write it C1 equal A. Okay. Now y at pi equal B. Substitute. I have what? Let me do it. C1 E pi cosine pi plus C2 E pi sine pi. That should equal to B. This is 0. Here I have what? C1 E pi times minus 1 is equal to B. Okay, so I have C1 equal A, and I have C1 equal what? Equal minus B e to the power pi. And C2 can be any value. So to have infinitely many solutions, so I have infinitely many solutions, infinitely many solutions. Since C2 any value, C2 any value, no restriction in C2. If this is equal to this, if A equal minus B A pi, and C2, no, so because of that, I have infinitely many solutions, because C2 has no restriction, no restriction on C2. So I need to check to be sure in C1, these two C1s are equal to each other. So I need B to be equal what? Yeah, C1 A pi times minus 1 with A not equal to 0. Is it? B equal what? Yeah. From here, I get what? If B equal, no, it's not C1 equal this. It's minus C1 A pi equal B. Huh? So B should equal to what? Minus A pi. If that's correct, then it means the two C's are, I mean, this is okay. But C2, no restriction in C2, so you have infinitely many solutions. C1 will be fixed, but C2 is any value. So I have to have this restriction, then I have infinitely many solutions. By the way, this is about boundary value problem, which is we don't have it in this section, but yeah, but the ideas can be. I think the idea is easy to understand. Let me stop. Yeah, let me stop the recording. I think we did good number of questions. Thank you.